Yeah. Strength has improved 43. Okay, fine. I think you need to log in with your roll numbers, right? Okay. Alekia, Aryan, Dinesh, Archana. You people change your name, add your roll number to your name as well. Yeah. Bhavesh, Anirudh. Yeah, they are changing. Good, good. Manisha, Anjusri, Prudvi, CR, Ananya, yourself. Fine. Yeah, good afternoon, everyone. Good afternoon. So, how is it going from morning?
Good, sir.
Okay. So, is it good to have an online class than offline, or is it good to have an online class in this type of situation?
Offline
Oh,
only better, sir.
okay, fine, fine. Hope so. Everyone say direct interaction class is much better than this online, right? But as we need to survive this pandemic, right? There we should go with the ways whatever we have. So let us see. And actually, uh, to be quite what's say genuine, I think I'm not prepared for with the appliances for this class. Actually, I forgot to get the slate. So in general, we will talk about the introduction for Unit 2. And no doubt, we have some part left in Unit 1, which need to be concluded. I will definitely do it once we get some rhythm in this online class. Okay. So we haven't interacted online till now, and it will be just halfway interaction in general. How better I could interact. I will try to get better interaction with you people online. Fine. So hope so. We will start a new topic from today. That is Unit 2, the network theorems. Okay. So we will start with some basic concepts of Unit 2, where we will be talking about some theoretical part today. And anyhow, we have lab in the afternoon tomorrow. So I will try to engage most of them in for your theory topics, so we can do the lab sessions when it comes for offline, right? So it will not be practical to do the experimentation for lab exam for lab in the online. So better we will use that 3 hours of lab as well for classwork, so that we can cope up with the syllabus completion as well, which will be a dual benefit as well. Fine. So we can say for complete the syllabus, we can do the lab experiments when it is offline. Is that okay?
Yes, sir.
Fine, fine. So let us, yeah, fine. But somehow it will be some lagging, right? For waiting for responses. Okay, let it be. Who is this host, Madam Anupama?
Sir?
Ma'am, sir, recording అవుతుందా ma'am?
Yes, sir. I'm recording, sir.
Okay, thank you, thank you, ma'am. Thank you, ma'am. Okay, so let me share my screen first. Yeah, is the screen visible?
Yes, sir.
Okay, fine. So let us talk about theorems, circuit theorems in today's class, where the topics concerned with unit 2 are introduction, and we discuss about some linearity properties. So what do you mean by linearity, or what do you mean by linear circuit, or what do you mean by linear element as well? Fine. And we have 5 theorems in our syllabus. First, starting with superposition, reciprocity, Thevenin's, Norton's, and maximum power transfer theorem. So please let me know if there is any difficulty in hearing or seeing the screens.
It's fine, sir. You can.
Yeah, fine. Thank you. So whenever it comes for the large circuits, finally, when you have any electronic circuit or a complex circuit which needs simplification for known reasons, say to find the current through a particular element, or to find the power that is being dissipated by or consumed by a particular resistor or any element, we need to simplify or find the currents and voltage values of voltage across such components, which requires without theorems, or say with the general procedure which we learned from circuit reduction techniques, whether by combining series circuits or series parallel combination circuits, or by using nodal or mesh analysis, it could not be possible, always possible to reduce the circuits. We can do it, but it may take, it may be a lengthy, sometimes it becomes more complex in solving, and sometimes it will not be appropriate for using such only say such techniques for evaluation. So we have certain theorems which give more easy way, or which provides the easiest way for obtaining the values which are required. So each theorem has its own specific application, no doubt, and they differ from each other in some terms, such as Thevenin's theorem. The first of fundamental theorem which we consider is a superposition theorem, and later on we go with Thevenin's, Norton's, reciprocity, and maximum power transfer theorem. So theorems are not just used to reduce the complexity in the calculation for finding the current or finding the parameters, say current, voltage, power, etc., resistor, whatever. So all the theorems which you are studying here are meant for linear circuits. So what do you mean by a linearity property or a linearity? A linear circuit is that it should possess a property of homogeneity. What do you mean by homogeneity? In general, there should be a scaling, appropriate scaling. Say if suppose I have a circuit where consider any simple a circuit with a voltage source and a resistor. If the value of resistor is 10 ohms and the value of voltage source is 10 volts, definitely there should be a flow of current of 1 ampere. And if you increase the value of voltage to 20, the current should also proportionally increase to 2 amperes. Or if I reduce the resistance to 5 ohms, keeping the voltage source as 10 volts, there are also the current has to decrease to 2 increase to 2 amps. So that means there should be some ratio between input and output. Even if I have an increase in input, the output has to be increased proportionally. So that what you call it as homogeneity, or you call it as simply scaling. Both sides, just multiplying with a scaling factor on both sides should be equal. Just multiply k into I and k into V, the product should be equal to k into IR, just like a homogeneity property. Additive property, the sum of the it should obey something like KVL, additive property, and these are the fundamentals of this linearity. These are the basic elements of linearity property. And which circuits are called as linear circuits is that a linear circuit is one whose output is linearly related to its input. You can see the graph here where, okay, which passes through the origin here. The sorry, which is a straight line which may be even pass through the origin based on the characteristics relation between voltage input and output. So the property, we have seen the property of linearity for resistor, and we also studied about in the first class about linear and non-linear elements, right? So if there is a fixed ratio between input and output, then you call it as a linear element. So any circuit which consists of linear elements are called as linear circuits. That is what given here, right? Resistor, inductor, capacitors are considered as examples for linear elements, right? And what is a linear circuit? It consists of linear elements, linear dependent source, independent sources, whatnot. What are the elements which has linear property of linearity can constitute or can be used in the construction of linear circuits. So unless we have a relation of products, say I into R or V by R, that doesn't matter. But if there is a term called as I square R or V square by R, where there is a squaring property, then it becomes a linearity. Sorry, non-linearity. Fine. So any circuit which obeys Ohm's law, in general we consider it to be a linear circuit. So that's a general statement which you can give for a linear circuit. And we are applying the same statements for linearity property for other elements as well, right? So we'll talk about these problems a bit later, because I'm much interested in discussing about superposition theorem first compared to any others, because it's a fundamental and easiest one. So let me introduce this first, later on we go for the other, right? So the superposition theorem. So what is the statement given for a superposition theorem is that the superposition theorem states that the voltage across an element in a linear circuit is the algebraic sum of the voltages across that element due to each independent sources acting alone. We can say the same statement in terms of current as well. What is that? Is the superposition theorem states that the current through an element in a linear circuit is the algebraic sum of currents through that element due to each independent sources acting alone. So whenever you consider any circuit, it is not mandatory that we should have only one current source or a voltage source. So sources could be anything. So you can assume any multiple source networks, right? So whenever you have a multiple source network, to find the response in any of the element in the circuit, we can use superposition theorem to find out the current through any element in the circuit, right? So just like what we do in the mesh analysis and nodal analysis, what do you do in the nodal analysis or mesh analysis? You find the current through branches, right? Or loop currents or through branch currents, right? So now we can use the simple principle or the superposition principle for calculating the currents, but we will not do it apply same just like mesh analysis. But what we do is we will go in a procedure for finding the currents in any required element. So what we do first is, suppose if we have a circuit, let me give an example, just like this. See, how many sources we have here? Two sources. One is voltage source, another one is a current source, right? So in general, when you go for what are the previous methods we have is use KVL or KCL for finding the current through. So what is required here is to find V in the circuit, right? V is the voltage across 4 ohm circuit, 4 ohms resistor. So in general, what we do with our till now what we have studied is mesh analysis or nodal analysis, right? Or we use circuit reduction techniques as well for finding the voltage, but which makes the calculation not that easy. So what we do is we apply a superposition theorem. So while you apply a superposition theorem, what is the thing we have to do is, since we have two sources, one a voltage source and one is a current source, fundamentally what we do is we assume that, or we calculate the amount of current that flows through this element, right, or voltage drop across this element when only one source is acting. Only one source is acting. So what will happen for the other then? What we have to do with the other source then? During the same time, suppose say if I consider 6 volts as source 1 and 3 amperes as source 2, right? So if we are applying superposition theorem. What the statement means? The response or the current flowing through 4 ohms resistor or the voltage drop across the 4 ohms resistor is the algebraic sum of voltage drop that occurs across this 4 ohms resistor when these sources are operating individually. That means when I have two sources, when I apply superposition theorem, first thing, let me assume that only 6 volts is present. What about the current source then? What should be done for the current source?
We shouldn't consider that source.
Yeah.
We shouldn't consider that source, like make it a short circuit.
Yeah. So there is a fundamental analogy we are using here. See, for independent voltage source, we use a short circuit. Okay. So for an independent current source, we are using a open circuit. So what does it mean here is, suppose if I have to consider only one source, that is, this is a voltage source, 6 volts is a voltage source and 3 amps is a current source, right? Suppose if I want to consider the response in the 4 ohms only due to 6 volts source, then what should be done for the current source? Current source has to be open circuited. So when this is open circuited, this limb goes off, right? There will be no 3 amps current flowing here. Right. So what is the circuit now? The circuit consists of only 3 elements. What are they? 6 volts in series with 8 ohms and 4 ohms. So I think we can easily find out the current that flows through this resistor now. Isn't it? Since these two are in series, what is the current that flows in the 4 ohms resistor then?
Series.
Yeah. 8 and 4 will be in series. This is open circuit, right?
0.5.
Yeah, 0.5. The current flowing through this
Half
circuit,
ampere will flow, sir.
Yeah. Half ampere will be flowing through 4 ohms resistor. So if you are interested in calculating the current, you can calculate the current, or else if you want to know the voltage drop, you can write it as 0.5 into 4 ohms. You can get it as voltage drop across this as 2 volts. This is a case 1, right? So in the case 2, what should be done is we has to consider the current source, but not the voltage source now. Isn't it? So already case 1, we considered that current source is open circuited. Then we calculate the current through 4 ohms resistor. Now what we have to do in the second case now? We has to eliminate the voltage source now. So what is the replacement for voltage source when you are considering a current source here? The voltage sources has to be replaced by a short circuit. It has to be replaced by a short circuit, right? So what happens if I short circuit the 6 volts? How these two will be connected? 4 and 8 ohms will be connected.
Parallel.
Yeah, in parallel with 3 amps, right? Now, so how will be the resultant circuit? This the resultant will be a three element circuit where I have a 3 amps current source, 4 and 8 ohms will be in parallel. So we apply the current division rule. We can know that what's the current that flows through 4 ohms resistor, because we are not interested in 8 ohms current flowing through 8 ohms. However, we are much interested in calculating the current that flows in the 4 ohms. So what is the current that is going to flow through the 4 ohms now? The current gets divided into 2 parts here. So what's the current division rule? If I assume the current flowing through this as 4 ohms as I1 and current flowing through 8 ohms as I2, what is the total current equation given for I1? I1 is equal to total current. What's the equation for the current division?
Total current into resistance of what is to be found by R equivalent.
I think, okay. Total current into opposite branch resistance by total resistance. I hope so. That's the equation, right?
Yes, sir.
Yeah. So now what's the current that is flowing through this resistor will be as I1. If I consider that current flowing through 4 ohms is I1. So 3 into opposite branch resistance, that is 8 divided by total resistance, 4 plus 8. So what will be the equation? I1 is equal to 3 into 8 by 12. So what's the value get there? Is it 1.3? What's the value you are going to get? What's the value you are going to get?
2 amps. So it's 2 amps.
It's 2 amps. Is that correct? Do you get 2 amps there?
Yes, sir, 2 amps.
Yeah. Fine. So 2 amps of current is flowing through these when you consider the second case. So now what was the current in the previous case? First case was 0.5 amperes. And now when it is 3 amperes alone, it is flowing 2 amperes. And what's the direction of that current? So is that same or they are opposite to each other?
Opposite.
Is the direction of currents flowing through these 4 ohms, was it same as previous? Is the point
opposite?
Okay, how was the 0.5 amperes was flowing? It was flowing from top to bottom, right? Because this was open circuited. The current was flowing through this like this, isn't it? In the clockwise direction it was going. So the current was of 0.5 amperes was flowing from top to bottom, right? In the case 1.
Yes, sir.
Yeah. In the case 2, the current was also flowing from top to bottom, right? Because the current was dividing, the direction of current source was like this. The current is dividing, the current was flowing from top to bottom. So in both cases, in case 1 and case 2, the current was flowing from top to bottom. Isn't it?
Yes, sir.
Yes.
So since they are flowing in both the currents are flowing in the same direction, so the resultant will be sum of the 2 currents. Isn't it? So when 2 sources are acting at a time, what is the current that is flowing through these 4 ohms due to 6 volts 6 volt source is 0.5 amperes, and the current that is flowing through 4 ohms due to 3 amperes current source is 2 amperes. So 2 plus 0.5 is 2.5 amperes that is flowing through this resistor. Since the directions of both the currents are same, we are adding them. Suppose what happens if the current source was reverse? Well, current source అనేది reverse ఉండింది అనుకోండి, direction of this current source.
It would have been 1.5 amps.
Yeah, we could have written it as 1.5 amperes, right? So since it is not, since both the directions of currents are in the same direction, the total current was assumed to be 0.5 plus 2 amperes. So it is 2.5 amperes that is flowing through this resistor. Now, what is the value we need to find is the voltage drop across the resistor, right? So what's the resistor voltage drop you can write now? 2.5 amperes into 4. What is the voltage you are going to get? What's the voltage drop V you are going to get here?
Ten.
10 volts. Current flowing was 2.5 and the resistance is 4. So you get it as 10 amperes, right? 10 volts, sorry. See here, this is a solution that can be given. So what's the justification we can do here? When in the case 1, what you have done, the output, the current source is considered to be open circuited. So we assumed a current and we found that it to be the current flowing through this to be 0.5 amperes, right? And when it comes for this second case, forget about these equations. I just gave them randomly, right? Just take the circuits only. So case 2, we shorted the voltage source, we divided the current, we found it, and the voltage drop across V1 and V2. I said that V1 is a voltage drop across 4 ohms resistor in case 1. V2 is considered to be voltage drop across 4 ohms resistor in case 2. Sum of these two will give you a value of 10 volts. The representation which I shown here can be different from based on our assumptions, right? So what are the way of calculations we are using? It may differ. Fine. You can follow any of the procedure. All leads to this answer of 10 volts, right? So shall we solve a problem for? Can I expect some answers for this? So now let me, shall I once again tell you, explain about this superposition? So I will just go in a, I went in a random way. I will just go in a formal way, right? Just to conclude the superposition theorem, fine. So first we define the superposition theorem statement. What does the statement mean? So don't get confused with these multiple brackets. Just I want to ensure that I give the whole definition, right? So I give one of the definition which you can directly write as the superposition theorem states that the current flowing through an element in a linear circuit is the algebraic sum of the currents that flowing through that element due to each independent sources acting alone. That's what we have done, right? So what should be done when it is having multiple sources? Turn off inactive sources. That is, independent voltage sources has to be replaced with a short circuit, and current sources has to be replaced with a open circuit. And if they are dependent sources, we don't touch them. We use them as they are, right? And steps to apply superposition theorem principle. So how can you apply what are the steps involved? Turn off all independent sources except one source. If I have say multiple sources, even you can solve, you apply this even for a network with 3 or 4 voltage sources or current sources, doesn't matter. The procedure remains same. What is that? What has to be done first? You consider only one source at a time, turn off all the independent sources except one source, find the output due to that active source using nodal or mesh analysis. Repeat step 1 for each of the other independent sources. So you repeat the same for all the sources. If I have 3 sources, right, we will get 3 values of currents, right? And by repeating the same thing, what should be done first? If I have a network with 3 voltage sources, V1, V2, V3, what should be done? First, we consider only V1 present. What about V2 and V3? What should be done for voltage sources V1, V2 and V3? They has to be replaced by a short circuit, right? So if it is a current source, you can replace it with the open circuit. So wherever that voltage source, current source is present, you open it. And wherever the current voltage source is present, you short it. That's it. So after doing so, in the last step, what you have to do, find the total contribution by adding algebraically all the contributions due to independent sources. So you just add all the currents or voltages which we have calculated at the end, which will give the total response of the system, right? That's what you have been doing here, right? So now turn off voltage sources, make it to 0 voltage, and turn off current sources, that is open circuit the current sources. When can ultimate aim either in choosing a short circuit or a voltage open circuit is, we need to nullify the effect of the source. Suppose if it is a current source, I can't short it. If it is a voltage source, I cannot open circuit it. So that's the reason the voltage across, you know that the voltage across a short circuit is 0, right? That's the reason the voltage sources are shorted. And we know that current through open circuit is 0. That's the reason why the current sources are open circuited. Am I clear? So when we are considering one voltage source, the rest of the effect of other sources should not be present on the circuit. That's the reason why we short circuit or open circuit the sources. Either, right? Am I able? Is it clear?
Yes, sir.
Yes, sir.
Fine. So let us solve one of the problem. Fine. Yeah. Can I have as answer for this here? Find the current I in the network given using superposition theorem. See, where is the I? Where is I to be found? He is here, right? So what are the elements we have here? You have a current source, you have a voltage source, you have 2 resistors. Just get me the value of I. Case 1, case 2. So what do you consider first? I will just let me give you some insight, right? So you have a voltage source and you have a current source, right? So draw the circuit, and in the case 1, you consider only 80 millivolts voltage source and ignore this current source. So what should be done when you ignore the current source in case 1? What should be replacement for this?
Open.
Yeah, it is an open circuit, right? So when you give an open circuit, you will be having a circuit with 3 elements. That is, you have a voltage source and 2 resistors in series. Add them and find the value of current I. Since it's a series circuit, current remains same in all the elements, right? case 2. What should be done in the case 2? You consider only this current source, and this voltage source has to be replaced with a
Short.
yeah, we need to replace with a short circuit, right? Now, when this is shorted, you have 3-element circuit when the current is flowing in this opposite direction. So you know that when current comes here, it will be divided, and you know that these two are connected in parallel. And just like previous case, you just apply the current division rule, assume some current here, IA, IB, or I1, I2, or something, right? And you can calculate the value of current that is flowing here. See the directions of the currents, they are opposite to each other. So find the resultant and tell me the value of I. Am I clear with the circuit? Am I clear with the circuit?
Yes, sir.
Fine. So I'm expecting some answers.
0.2, sir.
Okay, 0.2 is one of the answer. Fine. Let me ask someone of your friends to confirm that. Is that the same answer?
Yes, sir. It is 0.2 amperes.
0.2 amperes. So what's the current that you got in first case when you consider only this voltage source? It is 80 millivolts divided by 0.4 ohms. So what's the current you are going to get? So you got it as, what's the current you got it as previously? So in the first case, you got it as 0.2 amperes, right?
Sir, can you show the case where the voltage source is shorted, sir?
Yeah. Is this fine?
Yes, sir. Yes.
Yeah. Are these people available? Rule number 25, 36, 54. Are you available? Yeah. Where is rule number 25?
Sir, your voice is not coming.
Am I not audible?
Yes, sir, audible now.
Okay, okay. Where is rule number 25? I can't see him. He's not available actually. Okay. Hemant, are you there? Hemant.
Sir, Hemant Reddy or some other Hemant, sir?
CR, you are CR. Who is his CR?
Sir, one more Hemant, sir.
Okay. What's his number?
63, sir.
53.
63.
53. Okay. Fine. So, fine. I see many, but some people are missing. Okay. I think they are inactive. Fine. So, you got the answer?
Yes, sir.
So, what's the answer at last? What is the total current that is flowing in that direction, which was asked?
0.5.
0.1.
Yeah, the direction of current was shown like this, right? So, tell me the answer for current which is flowing in this direction. Whether if the previous C, when you consider the case 1, what is that? We are considering only the voltage source. So the current is flowing in the said direction actually. But when you calculate it for second case, when the current source is considered alone and the voltage source is shorted, the current will flow in reverse, right?
Sir, minus 0.175.
Okay, let us all have the same single answer then. Let us see.
So it is minus 0.1.
Correct only, sir.
Yeah. It's minus 0.175 amperes. Is that okay?
Yes, sir.
Is it the same answer you got, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Fine. Then that's okay. Fine. Okay. Many of them responding in chat as well. Good. So I promise you that I will get some slate by next class or by for tomorrow's afternoon class. Fine. So okay. Can you try to solve this one? Use superposition theorem, find current Ix in the network given. Can you give a try for this?
Yes.
Yeah. So I will brief it once. Just listen. How many sources you have in the circuit now?
3 sources.
Yeah, I have 3 sources, 2 current sources and 1 voltage source, right? Isn't it? So yeah, so first case you consider when voltage source is present and 2 current sources are avoided. How can you avoid them? They are open circuit. They can be open circuited, right? Isn't it?
Excuse me, sir, I have a doubt.
Yeah.
Sir, what if there is a dependent source then? Like if there is a current dependent voltage source or voltage.
Yeah. We keep it as it is because see, if I see, consider this to 120 amps, right? Suppose if this was a current dependent current source, right? We will take as is. We will take as is because it has a coefficient here. It will be given in terms of some say I into some x or ix or some value will be given here, right? 5x or the how you represent it, the current that is flowing in somewhere else, right?
Yes, sir. Yes.
So we just keep it as is. No need to take off the dependent sources. Dependent sources will be intact. They will be present as they are.
Okay, so we should solve it with them in the circuit. Like we don't have to remove that.
No need to remove them. No issues.
Okay. Thank you, sir.
We'll also solve it. No issues. Once you just get habituated with this independent sources, then we go move on to the dependent.
Okay. Thank you, sir.
Okay. So someone trying to solve this?
Yes, sir. Try.
Okay. Let me know if you face any problem.
.05 amperes.
Yeah, 36. What's the answer?
0.05 amperes.
0.05 complete or for first case?
No, sir. Only when
Only
current
for
sources are
voltage source.
Only when?
Considering voltage.
Considering only voltage source. So what will happen when you have a say case one? Let us all do with the same procedure, right? Case one, you consider only voltage source, and what happens to the current sources? They can be omitted, right? They can be considered as open circuit. So what will happen now when this is open circuited? The circuit will become as the circuit will becomes like this, right? Isn't it? Is the screen visible?
yes, sir.
Yeah, the circuit becomes will like this, and we can assume that these two are connected in series because there is only one current path for the current to flow. So the current which you get in this case is only 0.05 amperes, right? So we can go for the same thing for case two. What is that? Considering a current source of 40 amperes and ignoring the current source 120 amperes and voltage source. So the current source is considered as open circuit, and the voltage source is assumed to be a shorted, right? So what's the current that is flowing in I2? How can you calculate the value of current of I2? Is by using this principle, right? The total current into
The
opposite.
final answer would be 20.05 ampere.
Okay, we'll reach on that. Okay, happy that you solved it. Just give me a second. Fine. Okay. So this is the second case. Am I clear with this second case? A simple logic, right? I have a current source. I want to find the current flowing in this 50 ohms resistor. So the current division rule is applied here. Total current into opposite branch resistance by total resistance. You got it as 30, right? And in case 3, I can consider 120 amperes current source, and I can short the voltage source and leave this current source here open circuited, and I can calculate the current to be minus 30 amperes here. Why? What's the reason for minus 30? Is the current is assumed to flow in the reverse direction here, isn't it? So I'm just applying the same old what is the circuit current division rule. The total current into opposite branch resistance by total resistance. I'm just getting it as minus 30 amperes. Is that what you got?
Sir, one doubt.
Yeah. Go ahead.
Can't we add the two current sources and calculate, sir?
We can do it, but see, the fundamentally the superposition theorem itself states that no need to consider two sources at a time. We can consider only one source at a time, and we can solve it.
Okay.
Adding two sources will create some say complexity in the calculation. That's the reason why we are going for a simplified methods, right?
Okay, sir.
So that's the reason why we are using this, and the resultant current, I think you get around 0.5 amperes. Is that okay?
Yes, sir.
Yes, sir.
Yes, sir.
Someone said some 25 amperes. Is that
Sir,
okay?
I missed. Took the sign as
Okay.
incorrect.
Okay, no issues. Now it's clear, right?
Yes, sir.
Fine. So we'll solve the rest of the circuits. Fine. Some examples for superposition, and we will discuss about Thevenins and Nortons in the next lab. Okay, or tomorrow's class. So be prepared for classes in the afternoon tomorrow. Okay.
Okay.
So I would, if someone has any doubts with the today's class, just please let me know before the other faculty join. So can I mark the attendance for all the people, because I can see a strength of 62.
Yes, sir.
Is there anyone who is
sir.
missing from morning? CR?
Hello, sir.
Yeah. 24. What happened? చెప్పండి.
What, sir?
CR, is the CR present available?
Yes, sir. I am.
Okay, Hemant, fine. Is there any, are you taking the attendance from morning, or is this directly
No, sir.
taken?
Direct. Only lecturers will taken.
Okay, fine. I'm able to see, scroll
sir?
down the numbers. Yeah, ma'am.
Sir, this is Ananya.
Yes, Ananya, here.
The
Yeah,
class is recorded, sir. So the ma'am said they'll take the attendance from the recording itself.
fine, very good. Then that's fine, Ananya.
Yes.
Okay, then if you have no doubts, then I would like to stop my class here for today. Thank you. See you tomorrow.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Thank you. Thank you.
Hello, good afternoon, everybody.
Good afternoon, ma'am.
Good afternoon, madam.
Very good. How did you celebrate your Sankranti?
So boring, ma'am.
So boring. Still classes are online.
Ma'am, we want
Ma'am, we
offline
want
classes.
college.
Come to college, ma'am. Ma'am, we want to come to college.
Ma'am, we want college.
Wait. We have to obey the government now. Okay, fine. I guess all of you are having some systems with you.
Yes, ma'am.
As well as Python in your systems. I told